loud. And so if you could you give me a hi or a hello in the chat so it logs that you are participating in class? Okay. Uh, so we had a lot going on past week, obviously. If you have any questions, if you have any comments, if you have any complaints or criticisms or anything like that about your exam, please send me a message over Canvas or an email. I don't want to do that during class time. So if you have any questions or comments or anything like that, please send me a message. Be as specific as you can. For instance, um, if you have a comment about question 16, part 3 or something, which many of you have, of various degrees, um, be specific and I'd be happy to talk about any of those. But please do that over email or over messages. Okay. So that's first comment. What was the other comment? So I believe I've graded everyone's exam that's come in, and I've graded everyone's project that's come in. If you still haven't finished the project, this is kind of more of an issue with my other class. Um, But if you haven't turned in the project, which now that I'm saying this, I think maybe everyone did. But if you're the one person that didn't turn it in, or the two people that didn't turn it in, I think everyone did. Uh, get it in, okay? Um, Overall, they went really well. Um, I think this class probably did better than my other class, um, as far as the project went. So scores were pretty high. It seemed to go pretty well. So if by chance you haven't, which I think everyone did, maybe there's two people that didn't turn it in yet. Um, please do so. Okay, please get that in. So I've graded everyone's project that's come in, and I've graded everyone's exam that's come in. So please, you know, if you have any questions, comments, or concerns about that, please let me know. As since you've taken one of the exams for this course, you'll notice, which I'm sure you did, that you'll have various scores, and the first score is the lowest score possible. Um, there isn't a way for me. I wish it just wouldn't even give you a grade after you took it, or give the student a grade after you took it, because that's not your real score. There's one question that it just gives you the last question, it doesn't even grade. It doesn't even attempt to grade it at all. And so you get a 0 for that. And then there's, as you know, there's many problems in there that it doesn't understand at all what you're typing in. And so it just gives zeros for that. And so so the first score you see is really low. I mean, there was a lot of people that, uh, started off with a failing grade or almost failing grade and then got an A. But it's because the system's not grading you correctly. And so I still have to grade it by hand, even though I don't have to grade the multiple choice by hand, but I still have to grade everyone's response, by hand or whatever. So you will have seen your score changed at least once from that. So I know that's confusing and strange because I've never taken an online exam or anything like that where it grades it once and then it's graded again and it's this giant boost. But it's just because, it's just because there's too many people that wrote the exam, and thus the system we're using doesn't agree on how it was written. So it's just if you've ever heard that expression, there's too many cooks in the kitchen. It's just that's the issue. Um, so I apologize that the second exam will be the same thing, and the third exam will be the same thing. The good thing is, at least your teacher is looking at your responses and not just ignoring it or just accepting whatever the computer does. So I look through it, um, everyone's response for every question, which you could imagine is time consuming. And at this point, it's actually easier just to grade exams on paper versus the online because I have to figure out what's going on with the computer and what it understood and what it didn't. But that's the system. So that's the system now, and it's kind of just catch up from um, the early days of the quarantine. That's the issue. So, bear with me, but at least I'm grading it, and you should have seen a significant increase in your score from your first score to at least one more adjustment. Okay. So be aware of that. I graded it. I don't think I made very many comments on the exam because I had so many to grade, but there are comments on your project. So if I graded, well, I graded everyone's project. So if you want an explanation of why you didn't get full credit for a certain question or something, I made comments on almost everybody's. So yeah. So that's project one. That's exam one. Project two, I think, is more complicated. I've always thought it was more complicated, but generally students do a better or they have a easier time with it. And I think it's because they're more interested in the result. I think they find it more practical. And so even though it's more complicated, they usually have higher scores and it usually and you have used Excel at least once before, going into project two. And we're not going to do project three for our class. Project three would be and has been the CO2 project where you calculate how much carbon dioxide emissions your lifestyle accrues and how you could make changes in your lifestyle to decrease it. So that was project three. But since we're doing 8 weeks, we're not going to do project three. So you won't have to do that. You'll have homework over it. You'll have homework over carbon dioxide, but you won't have actually to do project three. So project two is the one that generally students prefer, even though I think it's more complicated, and that will be tied in with our financial part of the course where you'll uh, you'll pick a career and then you will um, pick a house and you'll be able to find, how much your mortgage would be and versus your uh, income. And then we'll set up a 401k, like a retirement program, and you'll kind of be able to see what those figures will look like. So, um, generally students prefer that project over the weighted grade book. But I still think the financial project is harder, but generally students do a better job on it. So it's always amazing to me because um there's more involved. It's more involved, but anyway. So that's not this week, but it's I'll probably announce it next week because next week we'll start into chapter 10. So we'll talk about that again next week. This week is just I would say this is a normal week. We have to go over section 8 and section 9. I'm going to warn you a couple times about section 8, part 1 homework. It's the worst homework of this course. So, of the virtual course, it's the worst homework. So, I'll show you the tricks and I'll show you kind of how to not get too overly frustrated with yourself or with the computer with this. So, section 8, part 1 is the worst homework of the course. Okay. Some of it's because of the way it's written. I've tried to make adjustments to what I can to help students. The first semester I took over um, this course shell, it was, I mean, if you think it's bad now, you should have seen it then. It was really bad, and there was like 2,000 students taking it, and it was absolute mess. Believe it or not, it's a little better now. So I'll go over that. So be warned. Section 8, Part 1 is terrible. And I mean, the actual section material is not that bad, but the homework is pretty bad. So I'll show you what to do about that. And that might be an issue where I have to grade some of that by hand because it just doesn't fully understand every response. And that was the way it was programmed. So I do apologize, but then again, it's not my fault, but it is my problem. That's one of those, you know what I mean? Okay, so I'm setting up. We're going to talk about uh, Section 8, Part 1 and 2. And before I get set up and start doing all the lecture, I'll also say Section 8 is also hated because it has to do with straight lines. And that's something that generally students learned in high school, and they hated high school. And so they hate this section because it kind of reminds them of that. And also, it's right after the exam, so there's that issue too. Um, so what can I say? Don't don't if you had high school algebra or even in middle school or whatever your experience with y equals mx plus b was before, I would just let it go. I would let that go and just start anew because what I have found over the years is that this is the one section, section 8, students have the most frustrating time with, and I think it's because they had a negative experience before. So I would just suggest try to let those go. Just try to pretend it's a brand new subject. You it's all brand new and you'll probably have a better time. Those students that have never done this before generally do better than the ones that have done it before. And I think it's just that negative feelings they had from the past. So just whatever you learned in high school, just that was then, this is now, we're starting new. Okay. So I think that'll do better. All right. If you have any questions, comments, or concerns, you can always post them in the chat while we're going live. And it does appear that my audio is working, so you could also stop me while I'm going if you want to unmute your microphone and comment or ask a question or something like that while I'm going. Okay. So I need to clear the page. There we go. All right. Section 8 is about lines, and the way the book and the way the homework is set up is it's going to split it into two different sections, but it's all about straight lines. Let's just look at this first example here. So right there, you can see that's a straight line. There's this, what looks to me like a brownish straight line going on there. And then there's all these dots around that straight line, okay? There's numbers close to the dot. Each dot seems to have a number, okay? And then we have this grid. There's a grid going on here. And we have numbers over here going up and down. And then we have numbers over here going left to right. Okay. So what does all this mean? And there's this weird looking thing over here. I don't know what that is. So we'll have to talk about that. Of course, I'm lying. I do know what it is, but um, we'll just have to talk about it. Okay. Okay. So what's going on? Well, this is one of the most practical classes I actually teach. Even though it's lower content wise than the other ones, it's more practical. This is what actual math looks like. Well, not the straight line, but all of these dots. So most of the time, outside of class, outside of school, what you're given, what you actually analyze is just a Excel spreadsheet of numbers. So usually you are just faced with this giant pool of numbers that you have to figure out the pattern to of some kind or clean it up to the point where you can find the pattern. And that's what we go on, that's what we see here. So if you could imagine I deleted this brown line here, all those dots, that's what you would be given. So there's 2 points that you would be given. So let's pick on this one right here. Just talk about that for a second. So this one seems to correspond with the number 34 and 62. Okay. So what on earth is that? What's that talking about? Well, the label here, somebody's worked on this data, and this seems to be anxiety level out of 100. Maybe yours is already up here. I don't know. But this is anxiety level. So someone has done some kind of experiment or a poll or something, and they've measured people's anxiety level. Okay, this is the percentage of time spent on cell phones daily. Okay, so it seems like the more amount of time people spend on their cell phones, their anxiety level goes up. At least that's what this study is saying. Okay. And what they've done is they've put a graph, they've put a picture to those numbers. But just picking out one of them, this is, I guess, 34% of their day corresponds to they're at a level 62 out of 100. Okay, so that's what's going on there. Um, this number, the first number, the left to right number, the horizontal numbers, those are often labeled as the X numbers. Okay, so this is often just labeled as X, and this is often labeled Y. Okay, so sometimes X will be T for time, but in this case, we'll just label it X. Okay, now we have to agree on the order we list the numbers. Okay, so we always list the X numbers first and the Y numbers second. That's just what we've agreed upon. That's what we always do. That way we can agree. So this person was just given a list of X values that correspond to Y values, and they made a graph out of it. They made a picture out of this. And then they asked the computer to make a line out of it. And so what's going on is that even though it's not perfect by any means, there is a straight line that the that the data is moderately or pretty close following. Some over here it lands right on the line, and then over here it's way off. So over here you can see there's quite a bit of distance between the prediction and the actual value, Okay, and that is exactly what real math looks like is that you make a prediction, you're not too far off. I mean, it's not a wild guess, but this is the actual value, so we'd have 90, and then on that line that would be the predicted value. Okay, so we see that their anxiety is way higher than what was predicted. Okay. um and the more people we would test, the more accurate of prediction we could make. So that's the idea. So these are called ordered pairs, and we always list the X value first, and we always list the Y value second. Okay, that's the idea. Now, what on earth is this thing? Okay, this, that's the Y, that's the X. So we see the Y and we see the X. And then we have this number, this 2.1382, and then we have this negative 28 point or 0.898. Okay, so we have two numbers there. And what this is telling me is this is increasing that 2.1 each time, but it started at this value. Okay, we're going to go over this again, but that's the general idea. So this equation is this line. Okay, and if you wanted to, you can actually set up, um, if you're given the data, if you, well, even if you perform the experiment and somehow you do this, you can have Excel calculate that trend line for you and then output that. So that's your prediction. Okay, so we'll use that a lot. But that's the general idea. Now I'm going to explain that again as we go, but that's just the quick introduction. So it says, what is the slope of the model? Write a meaningful sentence about this. So what is slope? Slope is just rate of change. Okay, so how is this thing changing? So this is how it changes. This is the number of how it changes. All right, that's 2.1382. It's increasing by that each time. Each time it increases by that number. So that's another way of saying that it's a line. If it increases by an amount each time, absolute change each time, that's the slope. That's the rate of change. Okay, so this is my slope. Now, crazily enough, we use an M to represent slope, and that's pretty weird. And it has to do with the guy that developed this was French, and it's the French word to like climb a mountain, mountainous. So he thought of it as this is how the data is climbing. Okay, that's why it's an M. It's just because it's a different language. So it's in French. It's like mountainous. Okay, so that's why it's M. So what is the slope of the model? Well, the slope of the model is 2.1382 because it's climbing that each time. 2.1382. It climbs that each time. Okay. So the little guy is climbing up the mountain. That's each step it takes. Okay. It takes that amount. This is where it starts. It starts at negative 20.898. Now, where did this come from? They inputted it into a computer program and it was able to analyze it to find that line and it outputted this. And we're just examining it. Make a prediction for someone who's on the phone 50% of the day. How does this compare with the real value? Make a prediction. We'll see this a lot in the homework, and even right now, we'll see this a lot. So, prediction versus real value. What on earth does that mean? What does this mean by predict something and then versus the real value? So let's look at the example they're talking about. They're talking about 50%. So 50% would climb up here, and it looks like that's 79 to me. So it looks like we're thinking of this dot right here. This is at 50% of their day, is at a level 79. Okay, that's the actual value. That's the real value, is right there, is at 79. Okay. So I'm just going to put that right there just to remind myself. The real value was 79. Okay. I just had this sinking feeling that what if you couldn't see the page? So 79 is the actual value. The prediction is where the trend line is. So the trend line right here we see is above the actual value. So that trend line is the prediction. So we want to see what is the prediction, what is the value on the trend line at that point. And the way we calculate that is we take this equation and we calculate it ourselves. Okay, so let's do that. So y equals 2.1382. And then for x, we're going to put in 50. So we're putting in this 50 right there, minus 20.898. Okay, that's me putting in the value to find the prediction. So the prediction is you take the x, you plug it in the equation, and then you're able to find it. Okay, so now I need to find my calculator. All right, there it is. And now I'm going to calculate this. 2.1382 times 50 minus 20.898, something like 86. Okay, that's my prediction. The actual value is 79. The real value was 79. So how does it compare to the real value? It is more than the real value. So the prediction is more than the real value. Okay. That's that's the idea. Now, the way I got that number was by plugging it into that equation that's given to me. Okay, that's the idea. Okay. Okay. Now it says if someone had the max level of anxiety 100, what is their predicted percentage of time on their phone? This is kind of like giving me the answer and having me find the question. So before it was asking, make a prediction for someone that had 50% of the day, and they plugged in 50 into that equation that they gave me, and then I got 86. Okay. This time they're saying the answer is 100. What is X? So they want me to go backwards. So that's kind of confusing. So they're saying 100 is the answer. What is the number that makes that happen? What is the X value that would happen, that would make that true? Okay. So I'm going to plug this in. So now the output is 100. That's what they told me. Find the X, solve for X now. Okay, but how do I do that? So the way I'm going to do that is I'm going to add that 2898 plus 2898. Okay, that gives me 120.898 equals 2.1382x. And now I'll divide both sides by that slope. Okay. All right. So I think x equals 120.898 divided by 2.1382. All right. Now I'm going to get my calculator out. Hopefully you can see my calculator. Or hopefully it's showing it on the screen. So take that 120.898 and divide it by 2.1382. And I'm getting something like 56.5. If I round that to the nearest whole, it'd be something like 57. Okay. All right. What did I do? How did I know what I was supposed to do? If someone had a max level of 100, what is the predicted percentage of time on their cell phone? So in this problem, they're giving me the answer. So this time they're telling me you're all the way up here, all the way up here. Okay, so how much time is spent? So the way we do that, whoops, too many screens. Okay. We take our 100, we add 20.898. So we add that starting value, and then we divide it by 2.1382. That's the slope. And then we find this is what the X value would be predicted. Okay. So it's kind of strange. This one, they give me the output. Over here, they gave me the input. Okay. That's the idea anyway. Is this a positive or negative trend? Would you classify this as strong, moderate, or weak? Positive, negative. So the way we determine if it's positive if from left to right it's going up, and negative from left to right it's going down. That's what positive and negative would look like. This one, sorry for the flipping, this one is going up. So this has a positive trend. The more time they spend on their phone, the higher their anxiety level goes. So we predicted that if they were somewhere over here, they're almost at 100. And I suppose if they go past that, they're going to go past 100, right? Looks like you could go past 100% of anxiety. Some of you might be experiencing that now with this class, but hopefully not. So positive, negative trend. So that's what it looks like. So as it goes along, is it going up or down? That's where the positive, negative comes up. Now for this question, this example, this is a positive trend. So I'll just circle that's what I want. I don't want the negative, but I wanted to at least explain what that looks like. Would you classify this as strong, moderate, or weak? So that is bordering on an opinion. This example here is certainly either strong or moderate. It's not weak. I mean, some of the points are directly on the prediction. So we can see that even over here, we have points that are right on the line, right on the line, right on the line, right on the line. So this is probably strong to moderate. Okay. In reality, it's strong to moderate, that there is something to this trend line. So in real life, I would say it's strong to moderate. If I have to pick one of them, I guess I would say it's strong. There is a strong correlation between the amount of time spent on the phone to levels of anxiety according to this data. Okay, so that's what I'm going for there. So I'm gonna label this as strong. Okay. All right, that's a lot to throw at you at once, especially if you've never seen this before. So I'm gonna pause. Is there any questions or just comments about this material? Let's look at this one. I gotta clear the page. That's better. Okay. So again, we have some kind of data that we've been given. It looks like they had the computer find that line for us. The computer outputted an equation. We see that here. So we see the rate of change. We see the starting value. This says weeks after the start of the year. Okay. And then this is percent of people who exercise daily. Okay. So this one looks like it's going down, 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 down. So it looks like start 0 over here. That's about as high as it goes. It's the start. And then you go over here, which I guess would be the end of the year because there's 52 weeks in a year. So this is the last week is the lowest point. So it looks like as time goes on, the percentage decreases by this amount each time. We see that M value, that rate of change, is negative. So it's subtracting that each time. That's the slope. This is the start. Okay. Sometimes called letter B. All right, we'll get into that later, but that's the idea. So this is the rate of change. All right, there we go. Now, what is the slope for this model? Write a meaningful sentence about this. Okay, what the slope is just how it's changing each time. And each time it's going down by this amount. So it's changing by this, which means it's subtracting that number each time. So the slope, I'll just write m equals negative 1.4518. Okay, that's how much it's changing each time. Okay, but what does that mean? It means looking at this label here, it means the percent of people that exercise daily decreases by that amount each week. Okay. The percent of people who exercise daily uh, decreases by 1.4518 each week. Okay. So decreases is important to note because that's the negative value. So it's subtracting that each week, subtracting that number each week. Make a prediction for week 30. That's like saying, what if x equals 30 in that equation? Okay, so here's 30. We see the actual value for week 30, and then this is the predicted value. So the line is the prediction. We want to know what is the prediction. The actual value is here. It's not labeled, but I can figure out from the grid that it looks like it's just above 60. So maybe it's like 61. Okay. That's the actual value, but the predicted value is on the line. So we're going to plug in 30 for that value. So let me get my calculator out and I'll try to do that. So what do we have? We have 1.4518, but that's a negative. So I'm going to do the plus minus there times 30, and then plus the starting value was 98.396. So I'm getting something like 55%. 55%. So that would be what we would look at over here. We're predicting it's about 55%. Okay. So if x equals 30, y approximately equals 55 using that trend line. Okay. Is that above or below the actual point? The actual point looks like it's 61. We're guessing it's around 55. So this is below the actual point. And then it says by how much? Well, I think the actual point is something like 61. I mean, it looks like it is. It's right at 60 right there. And then it's just above that 60 line. So it's right around 61, 62. Let's call it 61. So that's 5 and 1, that's 6. So it is about 6 points less than the actual value. Prediction is 6 points less than actual data. Okay. So more people are exercising than we would have predicted for week 30. Okay. Only by 6 points, but still. In what week is the percent of people who exercise equal to 50%? That sounds like they're giving me the answer. So they're saying, what week are we at 50? Well, looks like it's somewhere between 30 and 35 is the prediction. Okay. The actual value is over here past 30, maybe around 36, something like that. But that's what we're doing. So they're giving me the answer and they're having me find the question, what value is it? Okay, so this is like, what if y equals 50? What does x equal? And I have to solve for that. Okay, that's the idea there. All right, so what is the slope? The slope is negative 1.4518. 1.4518 equals y equals x negative. And then what was that y-intercept? 98,396. Let me double check my 14518. 14518. That looks good. And then 98,396. 98,396. Okay. They're telling me it equals 50. So I'm setting this equal to 50. 50. All right, now I want to solve for x. Okay, how do I do that? First step is I'm going to subtract that starting value. 396. Okay, let me open my calculator. 50 minus 98.396, getting negative 48,396. Negative, run out of room here. Negative 48,396 equals negative 1.4518x. Okay, next step is to divide both sides by that slope. Right? Divided by 1.4518. And I'm getting 33, almost a third, a little bit more than a third. So around 33. Around 33 is what we're finding. So x approximately equals 33. So around the 33rd week is what we're predicting. Now, just by sight, we knew it was in between 30 and 35. So that makes some kind of sense that we're predicting it's landing here around 33 and a third is where we're at over here. Okay, that's the prediction. The actual value, 50, doesn't end up until after week 35, but that's the prediction. So in what week is the percent of people who exercise equal to 50? That's what we did it. Okay. Can you predict what will happen 10 weeks into the next year? So now we're going to predict the future. 10 weeks into the next year, well, what's that going to be? So the prediction, 10 weeks, so that sounds like 52 plus 10 because we started at week 0. Now we're going 10 weeks into the future. So this would be week 62. That's what it reads to me. So we want to see what would this be at week 62. So I'm going to plug in 62 in for x and see what the predicted value is. Okay. So I'll open my calculator and I'll have 62 times 1.4518. I need to make sure that's negative. And then plus 98.39. Uh-oh, is that a 6 or an 8? 6. And I'm getting around 8% of people would still be working out from that previous year. So approximately 8%, okay, from the last year. So we're saying as we get out here, all the way out here, we're predicting it's going to be only around 8%. So maybe I'll make a dot. Something like that. Week 62, we're predicting would be around there. So it would connect that like that. Okay. So that's part 1. Sorry for all the flipping. It's hard to get everything on the screen at once. I can scrunch it down a little bit. So you'll notice that we have actual data, that's the points, and then the trend line is the prediction. Okay, that's us averaging all of the difference between the points, and then we find this average over the whole thing, and we find that it's following a line. If it's following a line, then we can make predictions. So that's what we've done here. So it's a little confusing of there's actual data, there's the prediction that kind of thing. So please be aware of that. And be aware of plus or minus signs if it's subtracting it each time versus if it's adding it each time. That's important. There's the idea that the actual value versus the predicted value could be more or less. That comes up a lot in the homework, which we'll talk about later. Yeah, those are the ideas for part one. Are there any questions or comments about part one? Is there any questions about it so far? Okay. So there's more, I think there's more people than when I checked last time. So if you haven't yet, be sure that you've said hi or hello in the chat so it logs that you participated in class. So if you haven't done that before, please do. Looks like there's more people than the last time I checked. So make sure you're getting counted there. Section 8, Part 2 discusses how to create a model without computer assistance. Problems can still be solved in the usual way for predictions, although no discussion about the correlation is necessary. Doesn't make sense without a graph to look at. The slope is still a number that describes the rate of change, and the y-intercept is still the number that describes the starting point. General hint, x numbers are usually those that count things or the time values, and y numbers deal with the money or profit that result in the calculation. This is a good rule of thumb. X, if something's dealing with time, if something deals with time, that's the x value, okay? So usually what we're looking at is time and money, all right? That's usually what we're doing. Time and money is what we're of most concerned with, okay? Okay. Example, David sets a goal to increase his running distance by half a mile every week to help train for a marathon. He starts with 2 miles, create a linear model to describe the scenario. So this is the rate of change, half a mile every week. And then this is the starting value right there. And so we can come up with that line ourselves with y equals the slope times x equals, or I'm sorry, plus y-intercept. So that's the starting value. That's where he starts. And then he's increasing it half a mile each time. So here is how we see the equation would be written. So it's increased by half each time, and it starts at 2. Okay, so each week it increases a half, right? Use your model to find the amount of distance David runs after 10 weeks. And we can see they just simply plug in 10 for x right there. So they go 10, half of 10 is 5 plus 2 is 7. So we predict 7 miles after 10 weeks. Okay? That's the idea of the linear model. Use your model to find how long it would take to train the mini marathon 12 miles. So that's like in the previous part where they give us the answer and we have to find the question. So we have to find the x value for this. So they're giving us y equals 12. Find the new, how many weeks? Okay, so that's exactly what they did here. They set y equal to 12, and then they subtract 2, and then they divide by a half. So that's what they're doing. They're subtracting 2. Okay, so then we get 10. 10 divided by half is 20. So they're saying 20 weeks. It would take 20 weeks to get to that point. Okay, if everything goes according to plan, that's how long it would take to get to that point. All right. So we see that we still have that make a prediction, find, find the output, or what if you are given the output, what's the input? That's the idea. So we still have that idea, same idea, but now we have to find equation ourselves, okay, which can be more difficult. Clear this page, start from scratch. All right. Number 5, for every minute you spend with a math tutor, your grade tends to improve by 0.15% points. If you spend 2 hours with a tutor, how much would your grade improve? Originally, had a 65. Okay. So for every minute, it increases by 0.15 percentage points. Okay. We spend 2 hours and we originally had a 65. So that seems like that's the y-intercept to me. This is the starting value. We start at a 65. We're increasing by 0.15 each time, each minute. So this is my m, okay? So it seems like our equation is 0.15x plus 65. We started at a 65. We're increasing it by 0.15 each time, okay, every minute. Now, they give me an amount of time. They want to know the outcome. What's the outcome? So they say if x equals 2 hours, what's the outcome? But there's a trick because it says every minute and then they give it to me in hours. So that's a little tricky. That's a little tricky that they did that. So I need to convert that 2 hours to 120 minutes because that's the way this thing is set up. So I got to be careful about that. So 0.15, 120 minutes plus 65 should give me the new score, the new predicted value of the grade. So let's do that. 120 times 0.15, that's the increase, but we started at 65. So it looks like we're predicting after those 2 hours, they're going to get 83. Okay. All right. Any questions about that? Is there any questions, comments, or concerns about how I did that? Does it make sense? Is it clear why I plugged in 120 and not 2? Is it clear how I knew what the rate of change was versus the starting point? Any questions about that? Okay. A company spent 1.2 million on supplies for their business. Every day, they make an average profit of $10,910. How much profit will they have after 60 days? How many days go by until the company breaks even? Oh boy. So now we got to talk about break even. But we'll do that at the end. We don't have to worry about that right now. So we spent 1.2 million on supplies. Okay. Every day we make 10,910. Okay. Every day. Every day it seems to increase by this. That sounds like the rate of change to me. It seems like it increases by this amount. All right. But they spent 1.2 million. All right. The book goes over um you'll probably see it in those videos, in your lecture videos. But the book goes over lemon shakeup. There's a lemon shakeup version of the question where someone spends $90 in supplies to make their lemonade stand, and then they sell it for $3. And you figure out how much it would be break even. But this one, much larger numbers. We have 1.2 million that we've spent in supplies, and we're making 10,910. So it's a much bigger business than the lemonade stand, but it's the same idea. Okay. So first things first, let's come up with our equation. So I think we have 10,910 times x. Each day, that's what we're accruing. And then, but we spent 1.2 million. So we're kind of in debt there. So 1.2 million. Okay. That looks right to me. So that's our equation. That's what it looks like. How much profit will they have after 60 days? So how much profit after 60 days? That's like saying, what if 60 days passes? What do you get? So that's like x equals 60. So we can plug that in and find what that value would be, what the predicted value would be. Okay. So I'm going to ask my calculator to help me with that. So we have 10,910 times 60 minus, and it looks like we're still down there, negative $545 and negative $545,400. So they're still in debt after 60 days. Okay. And that happens, of course. It's only 60 days, right? It says, how many days until they break even? What is this break even? Break even is when y equals 0. Y equals 0 is the break even point when they've paid off all of their supply cost. Okay. So what is that? When y equals 0, we would have 0 equals 910 x minus starting point. Okay. And we solve for x. We want to solve for x now. Okay. Solve for x. That's what we want to do. Now, how do you do that? We need to add the y-intercept to both sides because we were subtracting it. Now we need to add it. Just do the opposite. Okay. And then we're going to divide by that slope, just like we did before. Of course, the numbers are getting much larger, but that's what we're doing here. Divided by that slope. And this will tell me how many days that'll take. And it looks like it's going to take 110 days for that to happen. So x approximately equals 110 days, right? All right. There's a lot going on there. So we spent we spent 1.2 million to get going. We're acquiring $10,910 each day. We estimated what it will be like after 60 days. And then we also calculated when we predict the break-even point will happen, which was 110 days. Okay. So that's the idea. Again, the book goes over a lemon shake-up example. You'll see that in the videos if you watch them, but that's the general idea. Okay. But I understand it's confusing. So is there any questions, comments, or concerns about that example that I can address? Okay. If no questions, I'll keep going. So that those were examples. Sorry for all the flipping, but those were examples of if they give me the slope, they give me the y-intercept, they give me the rate of change, they give me the starting value, then we make a prediction and so on. Okay. So those are the pieces of information that we're given. Now, what if they just give us points, the ordered pairs, and we have to calculate the slope ourselves? Is that possible? Can we do that? Yeah, we can. It's just a little bit more tricky. So some slope values will require a manual calculation. This is taken by dividing the change in y numbers by the change in x numbers. You can deduce that in this case, when a comparison of two time frames are involved, usually. So often x is time, and so usually we're talking about the difference in years or something like that. And you'll see that in this next example. Find the rate of change for a population of 94,387 in the year 2000. to the population of 168,913 in the year 2015. So we see we have the 2 years and the two values. Okay, so that's the idea. So they don't give us the rate of change. They're telling us to find it. We have to find it. Okay, so that's what we're going to do. So you take the difference of the values. That's the absolute change, right? Absolute change in the values, new minus old, over the absolute change of time. So 2015 minus 2000 is 15 years. So that's a change of people over the change of time. Change of people over the change of time. Maybe I'll do absolute change of people over absolute change of time. That's the idea there. And so we see on average, there's 4,968 people increasing each year. So each year it goes up that amount on average. Okay. We're averaging over 15 years. That's the idea. Okay. So for that, I had to find the slope, the rate of change myself. It wasn't given to me. I had to find it. So that's an example there. Question 7. The game Legend of Zelda started in 1986 with only one game. By 2019, there's 19 games that had been created. Construct a linear model and predict the total number of games by 2050. Okay, so this question is asking me to find a linear model, and that's y equals mx plus b, where we have to find the rate of change and the starting value. Starting value is given in the question. And then, not only that, then we have to predict how many games there'll be in the year 2050. So I have to figure that out too. So there's many things I have to do at once. All right, but we have to find that rate of change first because it wasn't given to us. So I have to find that first. So what is that rate of change? Well, 86 was only one game. And by 2019, there's 19 games. So what is the change in games over the change in time? Okay, so that's what I'm going to do there. Let's pull out my calculator. So 2019 minus 1986 is over the course of 33 years. So we have 18 games over 33 years there. So 18 over 33 is, a little bit more than half. It's about 0.54 repeating. Let's just call it 0.55. Okay. So each year is about half a game. That's what it seems like, based on average on this data. Okay. Now, what was the starting value? The starting value is one game, 1986. So I have M, and I think the starting value is just one. We started with one game in 1986. So I think the y equals mx plus b is y equals 0.55 x plus 1. We're increasing half a game each year. We started with 1. The way I set this up makes year 1986 year 0. Okay, so I'm going to write that down. 1986 equals year 0. The way I set this up. It's the easier way to set it up, but that's the way I set it up. So we're not going to plug in the year in the equation. We're going to plug in how many years have passed since then. Okay, so I hope that makes sense. So 2050, I'm not going to plug in 2050 into my equation. I need to plug in the difference between those. So 14 and 50 give me 64 years, I believe. Okay. So that means 64 years have passed for that 2050 there. And that's what I'm going to plug in. So I'm going to plug in 64 for x. Y equals times 64 plus 1. Okay. Times 0.55 plus 1 game. About 36 games. About 36 games. Okay. All right. Also, a lot of steps in that question because there was multiple questions within there. Well, I guess it said round to the thousandths. I just kind of ignored the rounding. It would be 0, 0 for the numbers I used. If we want to go back, we could go 18 over 33 and then times that by 64 plus 1. And so it'd be 35.909 if we were really strict on the rounding there. So maybe I should be better about that. 35.909 games rounded. So that would be if we cared about the rounding, but it's about 36 games. Okay. All right. Does it make sense how I found the rate of change? Does it make sense how I knew what to plug in? Because I did plug in the year, I plugged in the amount of time that had passed. I tried to at least say my train of thought of why I was doing this. This is the easier way of doing it. Um, but hopefully it makes sense how I did that. So please stop me um, if I say something that doesn't make sense or you think might be wrong. Not impossible. Not impossible at all. All right, James Bond movie franchise spans over more than 50 years in business. 1980, there was 11 movies. 1990, 17 movies. If the trend continues, we'll predict how many movies there were in 2020. Okay, so this question does not give me the rate of change, but it gives me some facts about how many movies there were at certain points in time. And from there, what we can do is we can just make a prediction, a line, and then plug it in for 2020. Okay, so let's do that. So how is this changing? What's the rate of change? So the rate of change is M is the amount of movies that are changing. So absolute change is 17 and 11. 17 movies from 11. The years are 1990 minus 1980. Okay, so that's only 10 years. And it looks like it's 6 movies over 10 years. Okay. If we want to put that as a decimal, we certainly can. It could be 3/5 also. So 17 minus 11 is 6. Yeah. 1990 minus 1980 is 10. Yeah. So 6/10 there, 60%. So at this time, within that decade, there was 60% of a movie made each year. Okay, that's the idea. So that's the rate of change. It's increasing by 0.6 each year, at least within that time. Now, what's the starting value? It's not 0. We're not going to worry about the 50 years. We're just going to say starting value is 11 movies. So 11 movies at 1980. So I'm going to put B equals 11. But I have to be careful because that means that 1980 is year 0. Okay, so y equals 0.6x plus 11 is my linear model. All right, there it is. Now they want me to predict 2020, but I set 1980 as year 0. So I have to go 2020 minus 1980. Okay, because I set 1980 as year 0, so that's our starting point, 11. So what's that, 40 years? So I'm going to plug in 40 for x. That would be my next step. Y equals 0.6 times 40 plus 11. Okay. So zero point 0.6 times 40 plus 11 is 35. My prediction would be 35 movies. Right? Questions or comments on that one? All right. In this example, paper clips cost 2 cents each with an initial delivery cost of $15. How many paper clips can you get for $20? So this is different than the previous page because 2 cents each, that's the rate of change. That's M. So they did give it to me this time. And the initial cost was $15. So they are giving me the rate of change and they are giving me the starting value. So that means my linear model, my equation is 2 cents plus $15. So that's my equation. But they say how many paper clips for $20. So that's like giving me the answer and having me find the question. So that's if y equals 20, what does x equal? That's the idea. So that's what I'm going to do. So 20 equals 0.02x plus 15. I have to solve for x now. How do you solve for x? Well, you're going to subtract 15 on both sides because it's being added, so we'll subtract it. Okay, so 20 minus 15 is 5. And now I'm going to divide both sides by that rate of change. See how many times that happens. Okay. So I have 5 divided by 0.02. So it looks like 250 paper clips. Okay. Right. So only $5 is going towards the paper clips themselves. $15 is going towards the delivery cost. Okay. But I think it'd be 250. All right. So in that one, they gave me the rate of change and they gave me the starting value, but they're telling me the total and they're having me find how many would fulfill that. So I have to kind of go backwards, and that's more confusing than going forwards. Okay. So let me know if there's any questions or comments about that one. I'm going to try 10. For online Math 123, the semester starts in week 1 with a full class of 24 students. After the first week, there's only 21. In weeks, after the first test, excuse me, after the first test, there's only 21 students in week 6. How many students will be expected in week 16? So this time, it seems like they're giving me week 1 corresponds to 24 students, and week 6 corresponds to 21 students. And then we have to make a prediction about week 16. Okay, so week 1 is 24, and week 6 is 21 students. So we have 2 points of interest, and then we have to make a prediction of week 16, how many students would be there if it keeps going down. All right, so they did not give me the rate of change for this one, so I have to find it. So I'm going to find it now. What I'll do is I'll take the absolute change of the values in students, over the amount of time. Okay. So 21 minus 24 is 3, divided by the 5 down here. So we have minus 0.6 each week per week. Okay, fair enough. So that's going down each week. Okay, but they want me to predict after week 16 how much it is. How many we start with? 24. So we start with 24. Okay. Now this is kind of strange, but I don't think I'm actually going to plug in 16 because we count week 1 as year 0, and that's really confusing. It's kind of a bad example. But in this case, it's like week 0 is week 1. So I actually have to plug in 16 minus 1 officially to get the right answer. So I'm going to plug in 15 to get week 16. It's kind of a bad example, but that's the way it goes sometimes. I wouldn't count this wrong if somebody plugged in 16, but the way it's set up, we would technically have to plug in 15 because of the way it's set up. So I'm going to at least show you the correct way. So it's 15 students. Now, I wouldn't count you wrong if you plugged in 16 there. But that's the idea, okay? That's the idea. So the thing I'm most concerned with this example is, does it make sense how I found the slope? Does it make sense how I found the starting value? From there, really finding the linear equation, that's the most important thing to me at this point in time, is that you would be able to understand that, okay? It's confusing of why I would plug in 15 rather than 16, but that's because technically week 1 was set to, just like in the previous examples, was set to week 0, and then that's 24 students. So that's kind of weird. So week 1 equals week 0. Okay, just like James Bond up here, 1980 is set to year 0. So we just plug in the years after that. So for weeks, we would just plug in the weeks after that. Confusing. For some reason, it's more confusing if it's weeks rather than years. I don't know if it is the same for you, but trying to read your mind, I would think that it is. Number 11, the server makes $2.13 an hour plus tips at a local restaurant. For each person that comes in, they make about $2.85 in tips. How much money can they take in an hour if they serve 8 people? Okay. So, what's given? What's asked? Let's figure it out. So, they make this amount an hour, and they make this in tips per person. So, there's a lot going on there. For each person that comes in, they make this. How much money would they make after they served 8 people? So it seems like we're going to plug in 8 there. We're told that it's within 1 hour. So this is confusing because they almost give us 2 rates of change in the question. We have to figure out what it is we're being asked. But we're told it's only 1 hour. The thing that's changing is the amount of people. So I think for this one, this is the rate of change, 2.85 times x, x being the amount of people that come in within that hour, plus the $2.13 that they make that hour. Okay, so if I plug in 8 for x, then I should get how much they made that hour. So that's what I'll do now. So 2.85 times 8 plus 2.13 equals what? 2.85 times 8 plus 2.13 is 24.93. So that's what I think they would make that hour. But that one's confusing because they give us like two rates of change, and you have to determine which one do you use depending on the question. But because they are giving me the amount of people, I'll use the per person. Okay. Number 12. In March, there's 540 employees at Alpha Factory. In June, there's 495. What will there be in November if the trend continues? So it doesn't seem that they gave me, um, I mean, they didn't give me the rate of change. They just give me some facts here. Okay. So January, February, March, I'll count that as month 3. I have 504 employees. April, June, so I count that as month 5. And there's 495. So I can count this as my points. So this is 3, 540. And then we have 5, 495. Okay. So now we can find our rate of change. So how much people have changed over how much time? I don't think anybody was going to correct me, were they? Ever say something out loud and you're like, that doesn't sound right? There we go. Okay. Minus 540 divided by 4. So we're decreasing by about 11 people each month. Okay. Now, if it's November, what's going on? Well, what do I plug in? Do I plug in 11 or do I plug in 11 minus 3? Which one do I plug in? That's the question. So we're starting with 540 x plus 540. That's going to make March month 0. So if that makes month 0, then I have to go November subtracting March, January, February, March. So that's 3. So that's going to be 11 minus 3. So I think I plug in 8. If I do that, times 8 plus 540, I think they're looking at about 450 employees still there. Okay. All right, that is
How
the
did
end.
you get
Oh,
November as month 8?
I didn't hear I heard you say something, but I didn't hear what it was. Something about month 8. What could you say it again?
Can you hear me?
Yes.
How did you get November as month 8?
So I think November is month 11, and I think we're going to have to set March as month 0.
Oh yeah, so yeah, how did you get March as month 0? I mean,
Well, that's where we're starting. Where they're telling us that March is the beginning. March is the beginning of my information. So there's 540 employees there. That's normally month 3. Normally June would be 6, and then I should change this. I didn't change that. So how many months have passed since March to November? So how much, what's the difference between March and November? So I think there's 8 months that have passed there. So after 8 months, how many employees are still there? I think it's 450.
Oh, okay. Okay, I see now.
To me, it's more confusing if it's months or weeks versus years. And I don't know why that is, but to me, week one, setting that to zero, that's more confusing. March to month zero is more confusing than going up here. And for some reason, this is clearer to me. Maybe it's just because I've done it more. I don't know. But setting this as year zero, and then every year that passes, that's what we're talking about. So here I plugged in 40 and not 2020. I plugged in how many years have passed since then. That's what I did. Okay. So I'm hoping, um, hoping that's clear. But thank you for asking because I'm sure you're not the only one wondered why would I plug in 8 and not 11. But I'm plugging in how many months have passed since then because we started with 540 in March and then now we're looking at November, so there's been 8 months that have passed. That is the idea. Okay, now that is the lecture on parts 1 and 2 for section 8. We need to, at the end of today, of our meeting today, we need to look at section 8, part 1 homework because it's tricky. It's tricky with what it wants, all right? But that's the idea with the notes. So I'll post these notes after class in the announcement, so you'll have those, okay? Um, Maybe we'll just look at the homework now and then we'll take our break. So I'm going to go down to student view. Section 8, part 1. Take quiz. No, it says quiz because everything in Canvas is a quiz, but it's not really a quiz. Okay. So this part 1 has to do with those dots. That's the scatter plot. So just like in class, we see that it gives us the equation. We see we have the dots around the trend line, and it's asking us questions. Now, this is a increase or decrease of blank amount of jobs every blank after the start of 1990. So this is the worst homework of the class. Okay, so I'm just warning you, this is the hardest homework of the class. Why? Because of the types of questions it asks. So at some point, a few years ago, maybe a year and a half ago, I added this. It's looking for increase or decrease. It's looking for an amount. It's looking for time. Before, it didn't even tell you that. You were just supposed to know. Okay, so students were very upset about this. But this is decreasing. Okay, so this is certainly decreasing each year. Okay, so each year it's decreasing. By how much? It's decreasing by 130.36. Okay, it's decreasing by that amount. And then every what? Well, I already said, and then the hint is it's a time. So every year it's decreasing. Okay, so that's the type of questions you're asked. But I throw in some hints to try to help you with what's going on. Now, it's decreasing this amount. So I didn't put a negative sign there because I already said it was decreasing. All right. Complete the sentence that describes the below. The number of blank has gone up or down by an amount every year since 1990. The number of jobs, okay, has gone down by 146.77. So because I put down, I don't need to put the negative sign. The down is the negative sign. So that's the idea. That's what we're looking at here. That's the idea. Now, this one I think we actually calculate something here using the graph below. What prediction expected trend line for the 15-week start year? So I would guess you would just plug in 15 for X and enter that value. Okay, so that would be like a normal question. But I have found that students really do not like where you have to fill in words to complete the sentence. They do not like it, but it's part of the homework. This would be just like what we did before. Use the graph below. What prediction expected using trend line for the year 1990. Now look at this. This y-intercept's huge. So they're actually plugging in the year for this trend line. It's not years after. It doesn't say that. It's not years after 1990. It's the actual year. Or not, I'm sorry, it's not the years after 1970. It's the actual years. So you would actually plug in 1990 for X there, question 4, and then write the value, right? This asks, what is the slope of the model? Well, it's 0.0478, okay? What is the meaning of this? Finish the sentence. Each blank, and it sure looks like year, that goes by approximately 0.0478 stars are found in the galaxy. Okay, so it tells me new stars or what's found. What is the predicted value for 2000? So we're either plugging in the year, how many years have passed since 1800, or we're plugging in the year 2000. So we need to look at this and see which one it is. It's minus 77. So I'm thinking you're going to plug in the years itself. Whoops, I meant to open the calculator. Okay. So I'm giving a big hint, on this homework, but this is always the worst homework. So that's how I'm justifying it. Minus 77.063. Hopefully I plugged that in right. Looks like it's 18.5. And for the year 2000, they actually found 23. What is the predicted amount? So I would put 19. So I would guess 19. The prediction is below the real point. Quantify how much is the prediction below the real point. So I found 19 approximately. The real value was 23. So 23 minus 19 is 4. So it's 4 points below the actual value. Okay. And so on and so on. But that's the idea with this homework. Okay. There's only 8 questions. It's not, terribly long or anything like that. But that's a hint of what you're looking at. Okay. That's a hint of what's going on. If you if it's not making sense, you can always email me. And then I think I programmed it so after you complete it, um, you'll see the answers it was looking for. And of course, you can attempt it more than once, but note it does randomize some things. So you're not going to get the exact same homework twice or even 3 or 4 times. So watch out for that, okay? But it's always the trickiest homework, so let me know. And even after it's done, I'm gonna have to grade it by hand because there'll still be correct responses that I haven't programmed in yet. I would try to add as much as I can every year. But like for instance, if somebody put new stars versus stars or new star or star capital S or lower like there's all those variations of correct answers that I might not have in there, so I might have to grade it by hand in the end anyway. So please be aware of that. Section 8 part 1, now not perfect by a long shot, but we got to have something, okay? So keep that in mind, but you can always send me a message if you have a question or something, okay? So that is section 8. Now, I think that was a lot. That was an hour and a half of me droning on and on. I want to take a 10-minute break, come back, talk about section 9. Okay. Section 8, part 2, much, much more straightforward. Okay. You don't have to fill in quite as odd of answers that. All right. So I'm going to take a 10-minute break. I'm going to come back and then we're going to talk about section 9, which is, I think, one of the more interesting subjects, exponential growth. Okay. So I'll be back in 10 minutes. That would be 10:45. Okay. Okay. If you're back, could you give me a hi in the chat? A hello or something in the chat? I hope your other classes are going well. Um, Hopefully everything is going well. All of my, I think almost everybody in my in-person 123, they said all of their other classes are online or virtual or whatever, and that was their only in-person class. Do you guys have any in-person classes? Or are they all virtual? Does anyone have any in-personal, like traditional, where you actually go to class? Emily's all virtual, just virtual. Okay. All right. For those who are taking virtual classes, let me ask you this. Um, is this typical of the format for the other classes? Is this similar to I mean, the subject's different, of course. Is this similar to what you guys do in your virtual classes, the way I do it? Is it similar, same, different? Are they still doing like just lessons and then it's self-taught, huh? And you for the self-taught, so is that do you guys meet on Zoom or is it you just watch videos and read out of the textbook? Okay, this is your only Zoom ones. Okay. Just textbook. Okay. Okay. Interesting. It's always interesting for me to hear. I get a certainly during COVID and pandemic when we were kind of figuring all this out, um, it was always so strange because it was like, oh, I wonder what other teachers are doing. Um, I didn't know. But then I have been able to kind of over the past few years, I have been able to peek at what other math teachers at Ivy Tech do, but I don't know what other subjects do, so I have no idea. And so, unless there's some really awkward video that gets posted on YouTube or something, I have no idea. Like, so the only online classes I've ever been to are the ones I hold. So it's always kind of strange. It's like, hopefully, hopefully this is the right thing, and it's just very strange. So, uh, hopefully it's consistent with what the other teachers are doing. For this class, it's they change the format all the time, like every semester, of like how much time is given for the meetings. And before I've had versions of the same class where we only meet for like 50 minutes a week. And so at that point, it's basically just like an office hour, and I can just answer questions live. I can't really teach anything at all because there's no time. There's no time. So everything is just like you're gonna have to watch the videos, and that's probably closer to what you said about not required. It's basically just like there's a 1 hour office hour. You can ask questions if you have questions, or I'll go over common common homework problems that give people trouble, but that's about it. Here we have about half the lecture time, so I can go over about half of the lecture. So I'm still going over an abbreviated version of what's in the textbook, and then but before all this, before the 8 weeks, before COVID or whatever, generally what happened is you would meet in class in person either. 3 or 4 days a week for about um I'd say it was I think it was 3 days a week for um about an hour and a half, something like that. And there was lots of time. You would go over all kinds of different problems. You would work in groups within the class, and then you come back, and there'd be like an hour, 50-minute lecture, and then you would break off into groups and work on the problem, then come back as a class and then talk about what you discovered. And then more and more, they just condense it down to, as small amount of time as possible. So you never know. You never know. So hopefully this class is good for you. So we're not going over the textbook line for line, but I've also found that, you know, if I can abbreviate it enough, I'm pulling out the ones you need for the homework at least. Um, so that's the idea. But I found that once we kind of settled on this format, that not much is lost, even though it's 8 weeks and we only meet half the time, that kind of thing. Not much is actually lost. I mean, it took a couple years to figure that out. There was a lot lost in the beginning, but now it's not so bad. And we skip a project. There was a whole nother project that we used to do, we no longer do. I saw somebody was taking anatomy, so I hope that's going well. That's one of the harder classes out there, so not because of Ivy Tech or anything, it's just a hard class. So hopefully that's going well for you. Um, I know that's a very difficult and intensive class. So, best wishes. Okay. So section 9. What's the difference between section 9 and the other sections? So, with section 8, everything was changing by an amount. That was what was going on. So, section 8, everything is increasing by an amount or decreasing by the same amount over and over. So, each year it increased by this. So, I think there was a couple examples where it increased zero point 0.6 each year. So every year it increases by that. Or we had some examples where it decreased, like the amount of employees at that company was decreasing by each month or something. Now it's going to increase or decrease by a percentage. And we looked at that with section 7 with two different types of change. This is going to be the type that changes with a percentage. So it might increase by 60% each time. So if it increases by a percentage or decreases by a percentage, that's exponential. That's an exponential change. So we call this exponential. Okay. So this is the homework that's going to be due a week from today. Okay. That's the idea. So if this changes by a percentage, it's exponential. A certain population of ants increases by 4% every week. If the population started at 500, how many ants will be there after 20 weeks? So each week it increases by 4%. And we looked at with section 4 that if it increases by 4%, then we're going to multiply it by 1.04. So that would be over 1 week. You would multiply that 1.04. But then you would multiply it by 1.04 again, and then again, and again. And you're going to do that 20 times. So it increases times 1.04 20 times. But we're not going to plug it in our calculator 20 times. That would be crazy. So what you do is you use the exponent in your calculator to be able to do this. So let me pull up my calculator and show you how I do that. Okay. So I'm going to multiply 500 times 1.04 20 times. That's the idea. So it's 1.04. And then the way my calculator will do it, I have this XY button. Most of the scientific calculators will have an XY button. Okay. So you want to do the XY button and it's 20 times. So that means we're going to multiply this 20 times. Then we multiply that by 500. And so you'll get this 10,095 or 96 ants. So that's how you're getting it's increasing by a percentage. Increasing by a percentage. So we had to use this X, Y button, some number to another number on the calculator. Some calculators use like a caret button. They might use like this. There's a button like this. Let me pull up my other calculator in hopes I could show you something that looks like that. Hopefully I shared my screen right. So let's see if I can show a different version of the calculator. So I want 1.04 and I want the exponent to be 20. So that's if I want it to be a 2, but I want it to be a 20. So I can press the X, Y button, the X to the Y, and then type 20, and it tells me what this would be. Okay, and then I can times that. This calculator is always so fussy, but times the starting value of 500, and we get 1096. Okay, so here on this calculator, we also have the X to the Y button. So we have uh, two different calculators, but same button. And sometimes you use the it's called the caret button on your laptop. If you have a laptop in front of you, it's the shift 6. So above the number 6 on your keyboard, there's a little caret button, this little caret button here, and that's what I'm talking about. So you might see that. Okay. We could also look at another. If you remind me after we're done, I can show you what it looked like on Desmos. We could also do that too. But this is how you do it. So we're going to multiply it 20 times 1.04. And the way you do that is the exponential. So you need a scientific calculator to be able to do that. You should also be able to have that on your phone. Um, there should be some kind of exponential button there. Okay. For some problems, the percent is not given. And that's kind of like the slope. Sometimes the rate of change wasn't given, so we had to find it. We can find inside the parentheses called a growth or decay factor by taking the newest number divided by the oldest number. Note the 1 is already included inside the growth or decay factor. An example, a church is tracking the attendance each week. It notices that in week 4, the attendance was 250. In week 5, it was 240. If the exponential trend continues, what is the expected attendance after week 10? Okay, so we seem to be going down. So 240 over 250 is 96. Okay, so it's going down 4%. And so they're saying, okay, each time it's multiplied times 96%, and this occurs 6 weeks times the original value, and we see where they get that 196. I'll calculate that for us here. So 0.96 to the 6 weeks. That's how many times we're going to multiply it times 0.96 times 250. And we get 196 people after 10 weeks. Okay. So that's the idea there. All right. All right. So hopefully that makes sense. Also, why did they do 6 weeks and not 10 weeks? Because they started at 4. All right. All right. Well, let's do some problems together from scratch and see what we would get. The price of a rare vase is $1,200. If it decreases its price by 8.1% every year, what will the price be in 25 years? So this is changing by a percentage. Okay. If it's changing by a percentage, this is exponential. But how do you find that? The way I'm going to do it is it's decreasing by a percentage, 8.1%. Okay. This is happening 25 times, 25 years. We're going to multiply it by its starting value. Okay, that would do it. So let's calculate that. So 100 minus 8.1%. Now I'm going to turn that into a percentage. I'll just divide it by 100. So each time, it's 91.9% of what it was before, each time. All right, but how many times? 25 times. So to the 25, and then I'll times it by what we started with. And so I'm finding it's $145.23. Okay. Most likely, this is someone's first time seeing this. Are there any questions about how I got that number? Is there anything I can explain again? All right, just stop me if there is, okay? Because I'm sure somebody that was their first time seeing that. So if it's confusing, please let me know. Number two, the number of local stores in a city was 80 in the year 2000. By 2001, it's increased to 85. How many stores should we expect in the year 2020 if the exponential trend continues? Okay, they're telling me it's exponential. All right, if they didn't tell me, maybe I would just assume it's a straight line. But they told me this is exponential. Okay, so if it's exponential, it's changing by a percentage. What's it changing by? They didn't give me the percentage, so they're kind of being mean on that one. So what's it changing by? Well, there's two different ways we can calculate that. We can go the value it was to the value that it became, and that's how the previous example did it. So they did 80, I'm sorry, 85 over 80. 85 over 80 is 1.0625. So let me write that down. 1.0625. And they called this either the decay factor or the growth factor. In this case, that's the growth factor. So you can do it that way. That's perfect. That's the number we're going to use in our equation. The other way, which ties into section 7, is 85 minus 80 divided by 80. That is the percent increase. So 6.25, it's increasing that each year. That's what's going on. Each year it's increasing by 6.25. So we see that all these ideas are connected here. And really they're all the same idea. So this is the growth factor. Okay. Now, we started with 80 at the year 2000. Okay. So 80 times 1.0625. And then how many times does this happen? How many times does it increase by 6.25%? 20 times. We started in the year 2000. We're going to 2020. It's happening 20 times. So that will give us what our predicted value will be after this happens. 6.0625. And that happens 20 times. And we're going to times that by 80. And our guess would be something like 269 stores. Okay. Something like that. Something like that. Approximately 269 stores. Okay. Is that clear? Is there anything I can go over again? Is there any questions? No questions. I'm just going to keep plowing ahead, but please stop me if there's any questions about this. During the semester, the tutoring center has an increase of 12.5 students each day of the week. If Monday there are 16 students, how many students would we expect on Friday 4 days later? So they're nice enough. They're telling us that this is happening 4 times. They're telling us it's an increase 12.5%. And we have the starting value of 16. So we can set this up and predict what it would be on Friday. Okay. So what would it be? Starting at 16, we're increasing by 12.5%. So that's 1.125 to the, and it happens 4 times. So I'm going to put that to the fourth there. Okay. So calculator, 1.125 to the fourth. All right. That's how many times? 16. So we're going to predict there's about 25, 26 students on Friday. Something like that. Something like 26 students. Okay. I guarantee this is someone's first time seeing this. So if that person has any questions or concerns about how I did this, does anything not make sense? Please speak up if it does. If there's any confusion whatsoever. Okay. So if that didn't make sense, or if that makes perfect sense, then I'm sure somebody will have a question over the next part, because the next part's even trickier. Some problems will ask us to solve for an amount of time. We do this by guess and check method, and this will become your least favorite method of the entire course. We have to just guess and then check to see if that's the answer. If that wasn't the answer, we have to make an adjustment. Okay. So we're not going to learn how to solve this exactly. We have to just guess, check, and then if that's right or wrong, we have to make an adjustment for the next guess until we get it. Right? So this is going to be using guess and check method. The reason why it's guess and check is because we don't have a way of solving for the amount of time. So every question before was given the amount of time. Now we're going to solve for it. Okay. So that's a lot more confusing. All right, let's look at the actual problem and then we'll do it. Snow melts at a rate of 8% per hour on a sunny day. The city has 2 inches of snow. How long until the snow is gone? For this problem, we'll count it as zero point 0.1 of an inch. Okay, tenth of an inch is considered gone. So setting this question up is zero point 0.1 equals, we started with 2 inches of snow. It decreases by 8% each hour, and the time is in hours. So we're solving for t. Okay, we're solving for t. Now I'm going to rewrite this. So they give me the answer. They're asking for the time that's gone. So 100 minus 8, I suppose, is 92. So I'll write 92 to the t. Okay, I'm solving for t. How do you solve for t? You solve for t using the guess and check method. Okay, which means you just have to guess what t is and see if you're right. And when you're not right, you have to make an adjustment. If it's too much, if it's too little, you're going to have to make the adjustment. Okay, so we just have to guess, just make a guess of what t is at first. and then make an adjustment. So I'm just going to guess 10 hours. I don't know. I don't know if that's right. I just have to make a guess. So don't ask me where 10 comes from. I just have to make a guess. Okay. Just making a guess, seeing if it's right. All right. When it's not right, I'll have to make an adjustment. Okay. So it's 0.92 to the 10th times 2. And when I do that, I get zero point 0.8, let's call it 0.87. Okay, so I'm going to make an adjustment. I knew it wouldn't be right, but something like 0.87. All right, I'm trying to get down to zero point 0.1. So that means I need to increase this. Okay, so if I increase this, I don't know, let's go 20, see what happens. So 0.92 to the 20th times 2 is 0.38. Okay, still not right, but I am getting closer. All right, I don't know. Let's try 30. 30 hours. See what happens. So 0.92 to the 30th times 2 inches, I get 0.16. So I'm getting closer, but I still haven't found it. Okay. All right. Guess and check method. It's going to be your least favorite method because you can't just solve for it. You have to find it. I'm going to guess 40. It's probably going to be too much, but let's see. 0.92 to the 40th times 2. And I see, yeah, I've gone over my goal here. I went over my goal. So with 40, I got 0.07. So I got to dial it back. It's somewhere between 30 and 40. Somewhere between 30 and 40. Let's try 35 and see if that's right. 0.92 to the 35th times 2. And that is pretty close. So if I round it, it's around uh 0.11. So I'm curious. That was 35. I'm curious if 36 would be even closer. It makes me want to try it. So 0.92, 36 hours times 2. And I see if I rounded this, this would be what my goal was. So I'm going to answer 36 hours. So 36 hours is how long it would take. Okay. That's using guess and check method, your least favorite method of the class, because you're not solving. You have to guess and then make an adjustment of either going up or down. Okay. I'm sure someone was confused by that because that's a very confusing thing in math class that there isn't just a way of solving for it. You have to make adjustments for it. So, are there any questions about what I just did? Don't ask me where the number 10 came from. I just picked something. Had to pick something to get started. And I can either go up or down from there. But I just had to pick something. So I picked 10. It was just what would happen after 10 years. Or 10 hours, sorry. Okay. Any questions about 4, how I figured out 36 hours? So guess and check method is how you can solve for the time that's passed. Okay. So you just have to pick a number and then make adjustments when that's wrong. So you're either going to increase it or decrease it. When I got to 40, you saw I went over the goal. I went too far. So I knew I had to come back. I had to come back. So I had to go. I picked 35. It was really close, so I was curious what would 36 bring me. 36 was closer, so I'm picking 36. Okay. Any questions about that? Now you can guess in math, there probably is a way of solving for this exactly. Okay. And it's not part of the class as the way to actually solve for it, but there is a way to solve for it exactly. Okay. But the way to solve for it exactly is it takes um it's at the very end. It's the last thing you go over in college algebra, or if you took pre-calculus in high school. So it'd be one of the last things as far as the algebra portion of pre-calculus you would go over. But you can do it. It's on your calculator, actually. So if you want to see how you could solve for it exactly, I'm going outside of the class now. You can solve for these things exactly. And the way you do it is you take the answer and divide it by the starting value. So divide by 2. And then you use this logarithm button, logarithm. So if I take the log of that and then I divide it by the log of the change there, 0.92 log, I'll get 36 hours. Okay. So you can solve for it exactly. There is a way. It's not that there isn't a way. It's just that it's outside of the class. So our official method, the method in the textbook, is guess and check method. Okay. So I just want to make sure that that's clear. It's not that it doesn't exist. It's just we're not going to go over logarithms. So that's the issue. Okay. How long will it take a deposit of $100 to reach $200 if the interest rate is 4% a year? Okay, so it sounds like it's increasing 4% every year. We want to know how long, so that's time. We're searching for time. Start at 100, end at 200. Okay, so 200 equals 100 times 1.04. It's increasing 4% each year. And then the amount of years is t. To solve for time, we have to do the guess and check method. Okay, solve for time. So I'm just going to make a guess. I don't know if it's right or wrong. It's probably wrong. I'm just going to say what happens after 10 years. And then I'll make adjustments. Okay, so I know it's probably wrong. I'll just make a guess and then go from there. So 1.04, 10 years times 100 is not quite enough. So it's only $148. So that wasn't enough. So I'll just write that for my notes. Not enough. Got to keep going. So I'll say, okay, well, what happens after 20 years? Just make another guess. I know I need to increase it, but I don't know how much. So 1.04 to the 20th times the original 100. And I see I went over. So now I'm at 219. So just for my notes, I'm going to write that this was too much. Okay. So I know I need to dial it back. I need to go backwards. So I'll cut it in the middle, see what happens after 15 years. And then from there, I'll make adjustments what might be needed. 1.04 to the 15th times 100. And I see that that's not quite enough. So I know I need to go up. So now I'm between 15 and 20. I don't know. I'll try 17. And then I have to get closer because I know I have to increase it, but I don't know by how much. So 1.04 to the 17th times 100. And I see I am getting closer, but still not quite enough. Just for my notes, I'm going to put 194 just to note, okay, I tried that. It wasn't enough. So I'm thinking I'm between 17 and 20 at this point. So it's kind of between 18 and 19. Let's see what happens with 19. 1.04 to the 19th times 100. I can see that was too much. So now I'm going to try 18. See what happens. 1.04 to the 18th times 100. And that's got to be, so it's either 17 or 18, right? It's got to be. So 17 wasn't enough. 18 looks like it's a little bit over to the 18th times 100. So I'm going to say it technically took 18 years to get the $200 because it's between 17 and 18. It's not really until you get to the 18th year that you get that 200. So I'm going to say 18 is the one. Okay. But that's confusing because I'm just guessing and checking and going, oh, well, it's between this year and this year. It wasn't exactly 200. And I didn't exactly solve for it. I just had to kind of go back and forth to get it. So I'm sure that's confusing to someone. Are there any questions about that? Now, as I say, there is a way to solve for this exactly using a scientific calculator. You can go the amount it becomes over where you started. So 200 divided by 100 is just 2. And someone could take the log of 2, log base 10, divided by 1.04, log of that. And that would give us the exact amount of years it would take. So we were right. It's between 17 and 18, but really if I have to pick a year, it's not till the year 18 that we get that $200. So I'm still gonna pick 18, okay, even with knowing that trick there. Okay. But logarithms is not part of the class. Okay. You have a video of me doing it, of course. You can hold that against me in the court of law, but that's not the method. The actual method is to guess and check, which is what I solved for, and then I used a fancy calculator trick to check. Okay. Which you don't have to do. Okay. I'm just trying to be clear of what's expected and what's not expected. I hope. And if there's any questions, please stop me and let me know, okay? Now, that's part one. Part two probably will make more sense to you. It's probably closer to what is in everyday language, and that is interest on money, like bank accounts, savings accounts, that kind of thing. So this is probably going to make more sense than the first part. So section 9, part 2 is the application of exponential models related to the last problem from before. So we saw that increase is 4% per year. For bank interest is added to a customer account using percentage. Interest can be done in three different ways. You could have simple interest, annual interest. That's what we did in the previous example. And then compound interest is when you get interest on interest. It's the best way for you as the customer, but it's the worst way for you as the accountant. Okay, it makes them the most complicated to calculate, but it's the best that you can possibly have to attain money on your money because you get interest on interest, which is great. Okay. I also want to mention that annual interest, compound interest, these formulas that we're going to use, they tell you the balance of the account. Okay. That's what the B stands for, the balance of the account. So it tells you how much money you have at the end. Simple interest only tells you the interest, doesn't tell you about the account. So you'd have to add the original amount to find that if you were interested. And I'll go over this with examples, of course, but that's the idea. This tells you the balance for annual interest. This tells you the compound interest, the balance, and this tells you just the interest. So sometimes we're looking for the interest after annual interest, and we have to subtract. Compound interest, we'd have to subtract to find just the interest. Okay, just warning you. So when we look at examples, that's why I'm doing what I'm doing. Okay. Okay. Simple interest, annual interest, compound interest. find the simple interest of $50 with a rate of 6% for 30 years. So they're telling me it's simple interest. We're over here. Find the simple interest. Okay, no problem. I'm going to use that formula. P is the principal, it's the starting value, which is $50 in this case. The rate is 6%, 0.06. And then the time is 30 years. So 50 times 0.06 times 30 is simple interest. But it'll just be the interest. It's not the balance of the account. So that's $90. I think I typed that in right. Times 0.06 times 30 years. They get $90. So that's $90 on top of the $50. So they end up with $140 total, but this is the interest. This is just the interest. Okay, simple interest just gives you the interest. Okay, hopefully that's clear. So now they have $140 total. What balance is in the account that starts with $675 and is compounded annually with a rate of 2% for 2 years? Compounded annually, that's like what we did for that last example over here. It's increasing by that amount every year. So it's increasing by 2%. Okay, so that's 1.02. And that happens 10 times, 10 years, and we start with 675. Okay, so that's that formula we see right here. 1 plus the rate. So that matches up with our section 7 and 9 part 1. Okay, so let's find that 1.02 to the 10th times 675. And we find the balance of the account would be $822.82. Okay, that's the balance. That's not the interest. All right, the interest on the account would be the difference. I would subtract those if I needed to find the interest, but it asked for the balance, so that's what I'm reporting. Okay, that's compounded annually. If there's any questions about this, please stop me and ask, okay? Now it says find the balance, $1,000 compounded quarterly with a rate of 0.5% for 25 years. Compounded quarterly. Okay. This was simple interest, annual interest, compound interest. I don't see any compounded quarterly here. There's no formula for compounded quarterly. So how do I do that? Well, that's where the compound interest comes in. Compound interest is found by compounding money at certain time intervals. Interest is added back to the account. So this is the formula I'm going to use for compounded quarterly. Number of times compounded, that's what it means, that pound sign there, or hashtag, I guess. Hashtag comp means number of times compounded to the time times the number of times it was compounded. The R is the rate, that's the percentage. And then the 1, same one over here, because if it increases by a percentage, it's going to increase that. Okay, let me set it up and then I'll solve for it. So we start with $1,000. Okay, 1 plus the rate. Now I better turn that into a decimal because that's when I'm going to plug in my calculator. Now this is only 0.5%, so this is 0.005. Number of times it's compounded quarterly, so that's a 4. How many times, how many years? 25, and it happens 4 times a year. So 25 times 4 is the amount of times it happens, which is 100. Okay, now I got to plug all that in my calculator, and that's a whole nother task of how do you do this. So the way I do it is I take the rate divided by the number of times it's compounded, and then I'm going to add 1, and then I'm going to take it to how many times that happens. 25 times 4. It happens 100 times. Okay. And now times it by the starting value. So that's what I think will be in the account, $1,133.06. Does anyone want me to calculate that again and see how I did that again? Does anyone want me to do it again?
Can you show the steps on how you calculated it again?
Absolutely. Well, hopefully I can. Hopefully it comes up with the same name. Okay, so I think this is the rate, but it's kind of confusing because it's 0.5%. So it's 0.005. Compounded quarterly, so 4 times a year. So I think that's where the 4 comes from. Okay, so I think it's 0.005 divided by 4 plus 1. So that's inside the parentheses. Now I need to take that to how many times this happens, and that's 25 times 4, so that's 100 times. So x to the y 100 times. So that's itself times 100 times times the starting value 1,000, and I got $1,133.06. Okay. So I do rate divided by the number of times it's compounded plus 1 to the number of times this occurs, then times by 1,000. Okay. There are calculators that you can just type in this exactly, but that's how I do it step by step. Okay. So order of operations is important. I think we'll have another example of me typing it in again, so we'll see it again. What balance is in the account after 80 years later that the initial deposit was 2,500 compounded annually with 1%? Okay, this is compounded annually. So this is 1 plus the 1%, 1.01. Okay, compounded annually, so just once every year, but it's for 80 years. And we started with 2,500. Okay, so 1.01 to the 80th, all right, times 2,500, 5,041.79. 5,079. That's the balance. Okay. That's not the interest. That's the balance. If we needed to find the interest, we would take the difference. We would subtract them. Okay. But that tells me the balance. That's what they asked for. So that's what I answered. Okay. What balance is in an account with simple interest after 22 years of a rate of 0.89% that starts with $600? So this is balance simple interest. And simple interest only tells us the interest. So that's confusing. So we have to be careful about that. All right, so the interest is the starting amount, 600, times the rate, 0.0089, because it's 0.89%, not even 89%. And then how many times it happens, which is 22. So we find this, but this will only tell me the interest. It won't tell me the balance. 600 times 0.0089 times 22, 117.48. That's the interest that they have found. But that's not the balance. The balance would be the interest plus the original amount. So I need to add that to 600. That's the balance, okay? So simple interest only tells us the interest. It doesn't tell us the balance. Simple interest only tells us the interest, not the balance. The others tell us the balance, not the interest. So that's tricky too. Calculate the balance after 204 months, $350, rate of 5.4, compounded daily. Compounded daily? Well, I don't see a compounded daily over here, but I can use compound interest and I can talk about the number of times it's compounded and then the time times the number of times it's compounded. Okay, so I'm going to have to do compound interest. It wants me to find the balance, so I can do that, but it's compounded daily. And here's even a more annoying thing. They told me it in months, so that's kind of annoying too. All right, so first off, that's aggravating that they didn't tell me. They could at least told me in years, because that's what I need. I need this in years, and it's compounded daily. So there's all kinds of things going wrong with this question. All right, so let me at least clean it up a little bit. So we have 204 divided by 12 years. So that's actually 17 years. Okay. Kind of mean that they are doing that, but it's math class, so you got to expect it a little bit. Compounded daily means 365 times. Okay. So now we know. But then how many we know in our equation, we're going to have to type in how many times this happens. So that's 17 times 365. So that's the number of times it will compound, 6,205. So I'm going to write that down for my notes because I know I need that. And what did I say? It was 6,205. Okay, so I'll need that in my equation. All right, so compounded daily. We start with $350. Okay, 1 plus the rate 0.054 divided by number of times it compounds, 365, to the 17 times 365. Okay, so they were mean to give me the months. I have to convert that to years. And then this is the number of times it compounds. But we found that to be 6,205. I'll use that in my calculator. Okay. So 0.054 divided by 365 plus 1 to the 6,205 times 350. And I'm finding their balance to be $876.44. 876.44. Double check my work. 876.44. Yeah. Let me show you how I calculate it. Double check my work. It's never a bad practice. So I take the rate divided by how many times it's compounded, add 1 to the, and then that happens 6,205 times the initial amount, 876.44. Yeah, it looks right. That's the balance. Okay. They asked for the balance. I'm giving it back. So that's my balance. All right. Calculate the balance after 15 years, 2,200, rate 4% compounded monthly. All right. This one, at least give me they're at least giving me the years. That's nice. It's compounded monthly, so 12 times a year. So I'll have to deal with that. But that's what is going on. So I know I'm going to have to do 12 months out of the year, 15 years. So I'm going to jot that down for myself. 12 times 15 is 180. So this is going to compound 180 times. Okay, let's see if I can build it. Move this thing out of the way. Okay. So the balance equals 2,200. 1 plus 0.04 over compounded monthly, and then 15 years times 12. Okay. So that's me setting up the equation. Now plugging in my calculator. Whole nother matter here. So we have 0.04 divided by 12 plus 1 to the 180 times. So 15 years, 12 times a year, 180 times 2200. 4,004.66 is the balance. If I wanted to find the interest, I would have to subtract these two. Okay. If I needed to find the interest, I would have to find the difference between those two. But that's the balance after the 15 years. But if I needed just the interest, I would take the difference. Okay. So to find the interest, it's balance minus starting value. Okay. Let me write that at the top. Interest equals balance minus principal. Okay. So if you need to find just the interest for annual or compound, you have to subtract the two. That'd be the only way to get it. Okay. So that is section 9's part 1 and 2. Calculator for compound interest, a little tricky, probably going to take a little practice to do. That's understandable. But I find that students, it makes more sense to them because it's dealing with money. So that kind of um, uh, makes more sense with their everyday life, right? Part 1, more difficult because you're finding these percentage change, and that's not something you're more often to find. So this would be more difficult to understand what the question is asking for, but not necessarily more difficult to calculate. Okay. All right. So that's 4 sections. You have 4 sections of homework and a quiz due. So please do that. 2 sections of 8 are due Friday, 2 sections for 9, and then the quiz is due Tuesday. Okay. I'll stick around for what questions or comments uh, that are there. But other than that, I hope you have a good week. Please reach out if you have any questions, and I wish you well in your other classes.